Welcome back to Engr Matt Academy. In today's lesson, we are looking at an Olympiad problem. Let's go straight to the problem. The problem on the board says solve 3 to the power of x plus 1 times 9 to the power of 2x minus 1 equal to 27 to the power x. Let's see the solution. Solution: 3x plus 1 times 9 2x minus 1 equal to 27x. When we have this kind of problem, the first thing that should come to your mind is to see if the base numbers are related. The base numbers are 3, 9 and 27. Are they related? Yes. Let's see why we say they are related. 9 is the same thing as 3 squared, right? What about 27? 27 is the same thing as 3 raised to power 3 cubed. This means we can convert 9 to base 3 and 27 to base 3. Let's do that. 3 raised to power x plus 1 times 3 squared raised to power 2x minus 1 equals to 3 cubed raised to power x. What we have just done is convert 9 to base 3 and 27 to base 3. Now that all the terms have the same base, we can now apply the multiplication rule of indices to this part of the problem, to the left hand side of the problem. How do we do that? Since we are multiplying and these numbers have the same base, we add their powers. That means we retain the base number and we add the powers. X plus 1 plus 2 into x, 2x minus 1. This should be equal to 3 raised to power 3x. Remember, 3 times x. At this point, we can now equate the powers. The base numbers are the same, so we equate the powers. So we have x plus 1 plus 2 into 2x minus 1 equal to 3x. Now the problem has transformed from an indices problem to a linear equation. Next, let's clear the brackets and collect like terms. We now have x plus 1 plus 2 times 2x, that would be 4x, 2 times minus 1 minus 2 equal to 3x. We have two like terms here, x plus 4x, that will give us 5x. Then plus 1 minus 2 will be minus 1 equal to 3x. Now we can solve for the value of x. So we take 5x to the right hand side of the equation by subtracting 5 from both sides. If we do that, we have 5x minus 1 minus 5x equal to 3x minus 5x. 5x we cancel out and we have minus 1 equal to 3x minus 5x will be minus 2x. To get the value for x, we divide both sides with the coefficient of x, and the coefficient of x is minus 2. So we say minus 1 over minus 2 minus 2x divided by minus 2. Of course, minus 2 will cancel out here and we have x on the right hand side. What about here? The negative sign will cancel out, so we have half equal to x. Therefore, x equals to 1 over 2. X is half. In this kind of Olympiad problem, first check the base numbers if they are related. If they are related, then you are good to go. Let us see another problem. Okay, here is the second problem. Solve 16 to the power of x over 2 equal to 8 to the power of x minus 1. Let's see the solution. Solution: 16 to the power of x over 2 equal to 8 to the power of x minus 1. The question again, are these numbers related? Yes. Let's check it out. 16 is equal to 2 raised to power 4 and 8 is equal to 2 raised to power 3. Since we know that 16 and 8 are related, we now express them in a common base by saying 2 raised to power 4 into x over 2 is equal to 2 raised to power 3 into x minus 1. Now that the bases are the same, we equate the powers. So we have 4 into x over 2 equal to 3 into x minus 1. 4 times x will be 4x over 2 equal to 3 times x, 3x, 3 times minus 1, minus 3. Now 2 will cancel 4 to give us 2. We now have 2 times x is 2x equal to 3x minus 3. Now we can solve for the value of x by moving minus 3 to the left hand side of the equation, and we move 2x to the right hand side of the equation. Let's do that. We now have 3 is equal to 3x minus 2x. How do we get this? Minus 3 moving to the left hand side of the equation becomes positive 3, hence we have 3, and 2x moving to the right hand side of the equation becomes negative 2x, hence we have minus 2x. Next, 3 is equal to 3x minus 2x is x, therefore x is equal to 3. That is that. 2 Olympiad maths problems solved. What about when the base numbers are not related? We will discuss that in our next lesson. If you gained from this lesson, like and share this video, and also subscribe if you haven't done that, so that you don't miss the next lesson. I'll see you there.